Brave volunteers, we're going to learn a little bit about gases. So can you grab a pair of gloves and a pair of goggles for me? Because we need to be safety minded first.
Mom, why do you need goggles?
Yeah, that's good. Alright, and you will get a long balloon. You will get a long balloon. And so, what are our balloons full of? They're air, they're full of gas. And so, what we're going to do is we're going to do an experiment and see what happens when we take our balloons full of gas and we cool it way down. So, what you're going to do is you're going to bring your balloon over here and you're going to stick it in the beaker of nitrogen. And we're going to watch what happens. There it goes. We're going to see if we can't fit all of these balloons in the nitrogen. Watch your fingers. Okay, you can bring yours. I'll stick this one in as well. We'll just stick all the balloons in at once. And we can see what's happening is our balloons are getting smaller because all of the gas in our balloons is getting closer and closer together. All of those moving molecules are shrinking down as it cools off. Because remember, it's really, really cold, minus 320. All right.
Oh, that's nice.
So now we can reverse the process. We have all of our molecules shrunk down and they're not moving as much, but now we're going to speed it back up again by taking it back out of the nitrogen. So what I want you to do is face the audience this way. And you can do the same.
Shout out to Alexis YouTube.
And go ahead and stick your hands out like this. And brace yourself. We can stick them together like that. There you go. And I will give you back your balloons, and we're going to watch what happens when we warm these back up.
Whoa, YouTube, that's so cool. That's so cool, YouTube. Back
And so what's happening here is you're watching the gas that was way cooled off is now expanding once again, and the balloons have reinflated. Except for this poor little guy, he got a hole in him, so he didn't reinflate. And once again, we have our gas has returned. Thank you so much. You can go ahead and take off your gloves and goggles.
Just to let y'all know, this is a field trip.
Okay, so there's another way we can observe the expanding of a gas from its liquid form. I'm going to add a little bit of my liquid nitrogen to this other beaker. There we are. And now we can see a little better this time, that there's something else to observe about our nitrogen. What can you observe? What do we see? Can you tell me? Yeah, it's bubbling. What you're actually seeing, you couldn't see before because of all the frost on my beaker, but it's actually boiling. The liquid nitrogen is boiling right now because its boiling point, even though it's a liquid, is way lower than water. You think of water as boiling, it has to be really, really hot. But for liquid nitrogen, this is really, really hot. And so what I'm going to do is, if I add the cork on the top of this beaker,
its liquid form.
It has one way to go out. It has this little gap here. But if I close this gap, then the nitrogen gas no longer has an escape. And so it's going to want to push the cork off the bottle.
Did y'all
And so
see
this
that?
is a way we can observe how the liquid, when it expands and turns to a gas, it takes up way more space because the molecules are moving around way more. So
Form, it has to have less energy.
it pops right off. So that's how we can